Far below the sea, at 36,000 feet, lies a trench where millions of tons of water press down and everything is lost in darkness. Going there feels almost like walking straight into death. China is racing to reach this depth, spending billions while other major powers can only watch in shock. You are probably wondering right now, what is this place? This deadly depth is called the Mariana Trench. If we talk about the Mariana Trench, it is known as the most dangerous and deepest place on Earth. To reach it, you must travel almost 36,000 feet down into the sea. Only then can you stand at its lowest point. Yes, we are referring to Challenger Deep. This is the spot that is accepted as the deepest place on our planet. And you may be surprised to learn that humans have already reached it several times. Although scientists visited the Mariana Trench many times, their curiosity never faded. During these missions, they identified a point that caught everyone's attention, and that point was Challenger Deep. Even today, only a handful of people have ever gone there, and it all began in the year 1960. In fact, in 1960, Swiss engineer Jacques Piccard and American naval officer Don Walsh explored this location, and they were the first to reveal its details to the world. They explained that this is a place in the ocean where pressure reaches its highest level, and it may truly be the deepest point on Earth. But knowing only this was not enough for humans. There was no further progress. 4 decades went by like this. Yes, you heard correctly. For 40 years, no new research was done here. But then in 2012, filmmaker James Cameron completed a solo descent that changed everything. Using the information gathered from his mission, research on Challenger Deep began again in 2019 and 2020, led by Victor Vescovo with the Advanced Submersible Limiting Factor. This became the most remarkable mission so far, and was extremely costly. So costly that many smaller countries could not even imagine attempting such a journey. But then China stepped in. In 2020, China decided to explore this area. And as you already know, China rarely backs away from a challenge. It always finds its own way of doing things. So China entered this mission with a new plan and introduced the Scalable Deep Sea Program. Talking about the Scalable Deep Sea Program, it was launched in 2020. Under this program, China carried out its deepest dive so far, using a submarine called Fendusha. After this dive, China realized that if they wanted more detailed information about Challenger Deep, they needed to move forward with smaller and more advanced steps. So they began developing compact, highly capable, and frequently deployed autonomous deep-sea robots. These robots could reach the ocean floor without a pilot, and return without any cable support. They were able to explore tectonic plates, boundaries, and the deepest ocean layers, sending valuable data back to scientists. This shift by China changed the deep-sea mission from a simple experiment into a full-scale operation. With these robots, China began uncovering the hidden secrets of the deep sea, one after another. The first question answered was what exactly exists at such extreme depths? And surprisingly, the answer was quite simple: cold seeps. In these areas, gases like methane and hydrogen sulfide rise from the ocean floor, supporting organisms that do not depend on sunlight. These organisms survive on chemical energy. Because of this discovery, scientists started seeing new possibilities. This energy process could be used to build a model for finding life on other planets or moons in our solar system. Along with this, a substance known as fire ice was also found here. Fire ice, what is that? It is methane trapped inside a structure of ice that burns when lit. Research shows that it exists in large amounts in the deep sea. However, extracting it is risky because even a small mistake could cause an underwater landslide or release greenhouse gases into the environment. But the story doesn't end with fire ice. China also discovered something else lying on the ocean floor: polymetallic nodules. They're mineral time capsules that have been forming for millions of years, and they contain exactly the metals China desperately needs. 1 ton of polymetallic nodules contains an average of 35 pounds of nickel, 19 pounds of copper, 13 pounds of cobalt, and about 891 pounds of manganese. These are the exact metals China needs for batteries, renewable energy systems, and advanced technology. Scientists estimate that about 300 billion tons of these nodules lie on the seabed. For China, this represents a direct solution to its resource crisis, sitting right there on the ocean floor, waiting to be collected. Now, when China's Fendusha submersible reached the depths of the Mariana Trench, it wasn't just making the deepest dive in Chinese history. The mission had specific scientific equipment on board to measure temperature, pressure, salinity, and other environmental conditions at these extreme depths. Fire ice forms under incredible pressure and low temperatures, where methane gas leaking from the Earth's crust gets trapped inside a crystalline water structure. The result is an ice-like substance that looks harmless but contains enormous energy potential. Here's what makes fire ice so revolutionary. Just 0.04 cubic feet of this substance breaks down into about 6 cubic feet of gas ready to burn or be further processed. This makes methane hydrate incredibly cost-effective compared to traditional LNG. From an environmental standpoint, fire ice is exactly what China needs for its carbon neutrality goals. When burned, it releases about half as much CO2 as coal and leaves almost no ash. This makes fire ice a top priority for any country trying to cut emissions while maintaining energy security. For China, with its ambitious goal of carbon neutrality by 2060, fire ice represents the perfect bridge fuel. But here's what makes this discovery even more significant. Fire ice isn't just found in small quantities. The deposits in deep-sea locations like the Mariana Trench are massive. We're talking about energy reserves that could power entire nations for decades. China realized it had stumbled upon what could be the most important energy discovery of the 21st century. If you like this video, be sure to subscribe and hit the bell so you don't miss any future episodes. Don't forget to share it with your friends too. Polymetallic nodules. Another key discovery is polymetallic nodules, which measure about 2 to 6 inches, look like simple stones, but are actually layers of metals built around a central core. They begin forming when something like a creature's tooth falls to the seabed. Metal particles slowly attach to it, creating layers at a rate of only 0.08 to 0.4 inches per million years. This means the large nodules China uncovered are tens of millions of years old and act like fossil records of the ocean floor. Their real value comes from the metals inside. Each ton contains about 35 pounds of nickel, 19 pounds of copper, and 13 pounds of cobalt, plus nearly a ton of other resources, including rare earth elements, and up to 881 pounds of manganese. Scientists believe around 300 billion tons of these nodules lie on ocean floors worldwide, with major deposits in the Mariana Trench. For China, which is facing shortages of these exact materials, this offers a possible solution. Instead of relying on unstable suppliers and fluctuating markets, China could gather these metals directly from the ocean. The discovery comes at a crucial moment. As the leading producer of electric vehicles and renewable energy technology, China's need for these metals is rapidly increasing. Traditional mining cannot meet global demand, and major deposits are controlled by other nations. Deep-sea nodules provide a new and potentially independent source of essential materials. 5. China enters the race. But then China came forward with a strategy that caught everyone off guard. In 2020, China decided to visit the Mariana Trench, and they entered the field with a completely new strategy by launching the Scalable Deep-Sea Program. The Scalable Deep-Sea Program began in 2020. As part of it, China carried out its deepest dive so far, using a submarine called Fendoje. After this mission, China realized that gaining detailed knowledge about Challenger Deep would require steady and more advanced efforts. So they began designing smaller, smarter, and more frequently used autonomous deep-sea robots. These machines could reach the ocean floor without a pilot and return without any cable support. They were able to travel through tectonic regions, boundaries, and deep ocean zones while sending important data back to scientists. With this shift, China turned its deep-sea mission from a test project into a full-scale operation. Here's where the real challenge becomes apparent. Cannot simply collect fire ice or polymetallic nodules. They are found at extreme depths where the pressure is overwhelming, a place suitable only for the natural deep-sea creatures that live there. But since we are talking about China, this country is already making serious progress in exploring the deepest parts of the oceans. China began actively developing a comprehensive range of autonomous underwater vehicles specifically designed to carry out large-scale deep-sea research and systematically map ocean floor resources. The most notable vehicles in this impressive lineup are the Shenlong series and the deep-diving Hai gliders, each representing significant technological achievements. Shenlong 2 became an important breakthrough in China's deep-sea work. This vehicle can reach depths of about 14,700 feet and comes with tools such as thermal imaging to detect hydrothermal activity, a laser scanner, underwater cameras, and a magnetometer. It completed its first test in 2014 in a freshwater lake, and later carried out 15 dives down to 14,580 feet, staying active for up to 31 hours. These tests proved the stability of its systems and marked a new stage in China's use of deep-sea drones. Building on the success of the Shenlong 2, the Shenlong 3 represented the next generation of Chinese deep-sea technology. It included more locally made parts like navigation sensors, processors, and camera units. It increased its autonomous operating time to over 40 hours and improved energy use. With its fish-like structure and advanced autopilot system, it completed a 96-mile underwater mission at depths reaching 12,600 feet, setting a national record for this type of unmanned craft. But the question remains about which of these unmanned vehicles could actually reach the bottom of the Mariana Trench. It seems unlikely that they could search for resources in the deepest areas of the planet. Yet in 2020, China tested a new Shenlong vehicle capable of diving to about 19,600 feet. Even at that depth, it carried out every task fully on its own while the operator stayed on shore watching the camera feed. As for the High-E series, these are deep-sea gliders designed for long observation missions while using very little energy. In 2017, the High-E 7000 set a world record for gliders by diving to 20,700 feet in the Mariana Trench. It gathered important data on water conditions and proved its strong design and ability to withstand extreme pressure. The Chinese aren't limiting themselves to reconnaissance and data collection. The country is also advancing toward autonomous deep-sea mining. It is creating drones that can function at extremely deep levels. One clear example is the Kaito 2 project, developed by researchers at Shanghai Tech University. In July 2024, its engineering model reached a depth of 13,450 feet for the first time, and successfully collected polymetallic nodules containing copper, cobalt, nickel, and manganese. During this mission, Kaito 2 also demonstrated remarkable flexibility by adjusting on its own to steep underwater slopes, soft seabed layers, and shifting ground, opening the door for large-scale mining of deep-sea minerals. Kaito 2 set 6 national records, including its diving depth and the introduction of multi-mineral drilling and collection systems. It also featured precise route planning and a metal-free cable system for steady lifting and lowering. Its ability to sense terrain and adapt its movement has been central to safely traveling across the rough and varied surface of the ocean floor. At the same time, the China National Offshore Oil Corporation created a special manipulator for deep-sea remotely operated vehicles called the Chilean arm. This light mechanical arm, weighing about 132 bellbears, includes 7 functions such as extending, retracting, rotating, gripping, pulling, pushing, and spinning. These abilities allow it to perform many tasks, from firmly securing a drill head to gently collecting sample boxes. The prototype passed ground tests in Shenzhen and was later put to use, completing accurate operations during its first mission in the Pearl River Delta Basin. Still, many are waiting for the moment when China finally sends this robotic arm to collect nodules at its planned depth of 23,000. What makes China's approach even more remarkable is its focus on building permanent infrastructure for deep-sea resource extraction. A new facility, the Cold Seep Ecosystem Research Center, is being developed as the world's first combined land and sea platform, created to study deep-sea zones where methane, hydrogen sulfide, and CO2 leak from the ocean floor. Construction began on February 28, 2025, in Guangzhou, led by the South China Sea Institute of Oceanography, under the Chinese Academy of Sciences. The project will take 5 years and is one of China's most extensive deep-sea research undertakings. The design centers on 3 linked subsystems. The first is a deep-sea laboratory placed about 6,500 feet underwater. It is a mobile manned station that can host 6 researchers for up to 30 days as they study fire ice directly in the cold seep environment. The second is a land-based facility with chambers that recreate seabed pressure, temperature, and chemistry. These controlled settings allow scientists to study biological and chemical processes, test extraction methods, and assess environmental effects before applying them underwater. The third subsystem provides essential support, including communications, power, logistics, and data management, to connect operations at sea and on land. This combined setup lets researchers shift instantly between real deep-sea conditions and laboratory models. It helps them analyze how methane and hydrogen sulfide-based ecosystems form, how gas hydrates behave, and how extraction could influence the carbon cycle. The marine unit includes interfaces for submersibles, long-distance cable links, continuous monitoring sensors, and robotic arms for sampling. The land unit includes thermobaric chambers and reactors that mimic cold seep chemistry and support the growth of chemotrophic organisms. The plan includes major expeditions in years 3 and 4, collecting samples and monitoring live ecosystems while land-based simulations run in parallel. In the 5th year, all systems will be connected, and the center will open to international partners, placing China at the forefront of deep-sea resource studies. What China discovered through its robotic exploration represents the most comprehensive research conducted on the deep sea to date. With these robots, China began uncovering the secrets hidden in the ocean's depths step by step. The first question scientists answered was, what actually exists so far below the surface? The surprising truth was quite simple: cold seeps. In these zones, methane and hydrogen sulfide leak from the seabed, allowing organisms that need very little sunlight to survive. These species rely on chemical energy to live. From here, scientists began to see new possibilities. For scientists, this discovery opened up entirely new possibilities for future energy technologies. The organisms living around cold seeps have evolved incredibly efficient ways to process methane and other gases, potentially providing blueprints for new energy conversion technologies. Along with this, the same technology could help create models for searching for life on other planets or moons within our solar system. But the most significant discovery was fire ice, found in abundance throughout the deep sea environment. This methane gas trapped in ice-like crystal structures burns cleanly when ignited, but extracting it safely presents enormous challenges, because even a small error can trigger underwater landslides or release greenhouse gases. Data collected from the ocean floor also revealed objects that looked like potatoes but were not stones at all. These were polymetallic nodules filled with valuable metals such as cobalt, nickel, copper, and manganese. These resources are vital for EV batteries and renewable energy technologies. However, mining them can create sediment clouds along the seabed that spread across long distances and harm local ecosystems. Because of this, scientists warn that if the environmental damage becomes severe, it could take centuries for the area to recover. To understand why China's deep-sea mining operations are so significant, you need to understand the incredible journey from the ocean surface to the depths of the Mariana Trench. From sea level to about 200 meters is the sunlight zone, where bright conditions support corals, reefs, and many kinds of fish. From 200 to 1,000 meters lies the twilight zone, where light fades and pressure increases sharply. In this dim area, unique creatures like oarfish and sea angels appear. Below that, from 1,000 to 4,000 meters, is the midnight zone. Sunlight does not reach here, but many organisms create their own glow through bioluminescence. The giant squid and blobfish also live in this region. Farther down, from 4,000 to 6,000 meters, is the abyssal zone. It is quiet and stable, with only a few species present. Marine snow, made of carbon that has settled for millions of years, gathers on the seafloor here. The deepest layer is the Hadal zone, stretching from 6,000 to 11,000 meters. This includes the Mariana Trench and its lowest point, Challenger Deep, where pressure reaches extreme levels. Although scientists had visited the Mariana Trench many times, their curiosity never faded. Eventually they identified a point that drew global attention, known as Challenger Deep. Only a small number of people have ever reached it, beginning in 1960. That year, Swiss engineer Jacques Piccard and American naval officer Don Walsh traveled to this remarkable location and shared their findings with the world. They explained that this spot experiences the greatest pressure in the ocean and is likely the deepest point on Earth. Still, knowing only this much was not enough. Research did not continue, and for the next 40 years progress remained at a standstill. Then in 2012, filmmaker James Cameron carried out a solo dive that brought renewed focus to the region. His findings inspired further exploration. Using this foundation, Victor Vescovo launched a new phase of research in 2019 and 2020 with the Advanced Submersible Limiting Factor. This mission became one of the most significant and ambitious efforts ever attempted, requiring resources far beyond the reach of many nations. However, this story isn't just about technological achievement and resource extraction. Behind China's deep-sea mining ambitions lies a series of environmental dangers that could have consequences extending far beyond the immediate mining areas. When deep-sea mining operations disturb the ocean floor, they create massive sediment plumes that rise up and dissolve into the surrounding water. These sediment clouds aren't limited to just a few meters around the mining site. They can spread over hundreds of miles, affecting entire ocean ecosystems and disrupting food chains that have remained stable for millions of years. The particles in these clouds can clog the filtering systems of sponges, corals, and other marine life, threatening their survival and potentially causing ecosystem collapse across vast areas. Mining machines operating on the ocean floor produce constant noise and vibration that can disrupt the ability of deep-sea creatures to navigate and communicate with each other. Many deep-sea animals rely on sound for navigation, finding food, and locating mates. The industrial noise from mining operations could interfere with these crucial behaviors, potentially affecting reproduction and survival rates across entire species. The mining process may also produce waste containing heavy metals and other toxic substances that can spread poison throughout the marine food web, from microscopic plankton to large marine creatures. These toxins can bioaccumulate, meaning they become more concentrated as they move up the food chain, potentially affecting human food sources and ocean health on a global scale. Perhaps most concerning is the potential release of millions of years' worth of carbon stored at the bottom of the ocean. The deep sea acts as a massive carbon sink, storing carbon dioxide that would otherwise contribute to climate change. Disturbing these carbon deposits could weaken the ocean's CO2 absorption system, potentially accelerating global warming and undermining international climate change mitigation efforts. Fire ice extraction presents its own unique risks. Improper removal techniques could destabilize underwater geological formations, potentially causing underwater landslides that could trigger tsunamis. Additionally, if methane is accidentally released during extraction, it could contribute significantly to greenhouse gas emissions, since methane is much more potent than CO2 as a greenhouse gas. As we reach the end of this deep look into China's expanding deep-sea mining efforts, the overall picture becomes clear. China's search for new resources has taken it into one of the most remote environments on Earth, and the discoveries there may influence global economics, geopolitics, and environmental systems for years ahead. At the same time, the environmental impact could be significant. Deep-sea ecosystems that have remained stable for ages may be affected in ways that take centuries to recover. Disturbing carbon stores or releasing methane could influence the climate, and mining plumes or waste may spread across wide areas of the ocean, affecting marine species of all kinds. Geopolitically, deep-sea mining gives China a notable advantage. Their early progress may position them ahead of other nations in securing critical resources. Meanwhile, global rules for deep-sea mining are still being formed, allowing major players to shape future standards. Looking ahead, responsible development will be essential. Extracting resources while protecting long-standing marine ecosystems will be key to preventing today's solutions from becoming tomorrow's challenges. The international community now faces an important task, creating effective rules and environmental safeguards so that deep-sea mining supports global needs without causing lasting harm to the planet's most fragile systems. What do you think about China's deep-sea mining ambitions? Are the potential benefits worth the environmental risks? Should the international community do more to regulate deep-sea mining, or should countries be free to develop these resources as they see fit? The answers to these questions will shape not just the future of our oceans, but the future of human civilization itself. If you enjoyed today's video, please give it a like and don't forget to subscribe to the channel. Your support means a lot to us. Thank you so much for watching, and we'll see you in the next video.
Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.